Hello, this is Miss Chambers, and I'm going to walk you through how to graph f prime of x if I'm just given f of x. So looking at this particular problem, it says given f of x, graph f prime of x, and f of x equals x squared, a parent function we're really familiar with, the parabola. We're going to use something we're really familiar with to do something we're not so familiar with, which is graphing the derivative. One thing we've learned so far is the slope of the tangent line is equal to the slope of the curve at that point. And remember, derivative is synonymous with slope. So the way we're going to graph the derivative is we're going to use tangent lines to estimate slope at certain points, and then use our estimates to create a graph. So to start with, let's select a few points on the graph that we can find easily. X equals -2 would be 4, x equals -1 would be 1, 0, 0, and so on. So those are the points that we are going to try to estimate the slope of the tangent line at. So first thing we have to do is we have to draw some tangent lines on our graph, and again, we're estimating, so it's going to be very rough. But that's okay. It'll still serve its purpose. So let me just slide this around a little bit here. Rotate that a little bit. Okay, so our first tangent line at x equals -1 might roughly look like that. And so what I want to do is I want to extend the tangent line so that I can get some points so that I can count rise over run, because we're estimating the slope. So from here where it appears to cross at -1, I would rise 4 and go over 1, making my slope 4 over 1, but remember this line is negative, so it would be -4. So at x equals -2, our f prime of x estimate would be -4. Okay, and then at the next point where x equals -1, we'll kind of roughly estimate where that tangent line might be. And if we extend it a little bit, we can get a rise over run estimate. It looks like it's rising 1, 2, running 1. So at x equals -1, f prime of x would be an estimate of -2. And then at x equals 0, it's a special case. We have a minimum, and at minimums there's a horizontal tangent line. It's just a rule. So at x equals 0, our slope would be 0. And then, as we all should know, parabolas are symmetric, so I'm betting that at x equals 1, it's basically the same thing as at -1, except now my line will be positive instead of negative, increasing instead of decreasing. So instead of trying to extend and estimate yet again, I'm just going to assume that at x equals 1, f of x is the positive counterpart 2. And then I'm sure the pattern would hold for x equals -2. So now that we have that, we are going to move on to our graph of our derivative. And it's really important then when you're graphing the derivative, you label your y-axis as f prime of x, so that folks that come along and look at it know that they're looking at y values as the derivative of some function f of x. So let's see, at x equals -2, the derivative was -4, so I go to -2, -4. At x equals -1, it's -2, 0, 0, 1, 2, and 2, 4. So it would appear that our derivative, once we graph it, is linear. And this makes sense because once you learn about how to find derivatives using the power rule, the derivative of x squared is 2x. So it makes sense that our graph of the derivative would be a straight line. And that's how you would graph f prime of x given f of x.